The climax of a very long work, and you can feel the adrenaline mounting here.
What's everyone actually doing?
Everyone is at his own post, everyone has his own, task, but again, I would like to mention that this is the result of real teamwork. I would like to mention not only all the ESA people involved, but our friends from industry, the team led by Thales Alenia Space of France, our launch service providers, Eurocot, part of the RAN group, with their colleagues, Krunichev. A special thanks to the Russian army here in Plesetsk. They've been extremely useful. And of course, the European Commission, who is leading the Copernicus program, and EUMETSAT, our colleagues in Darmstadt, who will operate the marine mission of Sentinel-3. So we are all ready to go here.
That's some seriously important teamwork, Guido. I bet everybody gets to know each other. And of course, for you, you're becoming a bit of a regular, aren't you, over there in Plesetsk?
Yes, we've been in Plesetsk a few times. Last October, we launched Sentinel-5P. 2 years ago, we launched Sentinel-3A, the sister satellite that Sentinel-3B will soon join in space.
Guido Lovrini, thank you very much indeed. Best wishes to the teams there as we get closer now to the launch. We are 5 minutes and 31 seconds. We are looking at the pad here over there in Plesetsk, about 1,000, just under, I believe, kilometers north of Moscow. And we are getting closer now to launch, but earlier, actually several days ago, the satellite went through its integration phase. The satellite arrived in Plesetsk in mid-March, and since then it's been prepared for launch. Nick, do you want to tell us what's going on here?
So during this phase, the spacecraft was placed onto the mating adapter, which holds the spacecraft in place between the launcher and the rest of the satellite. The whole thing was then bolted on top of the Breeze upper stage. Now this is a very delicate operation since both the Breeze KM and Sentinel-3 were fueled at the time. Then after that, there was the encapsulation inside the fairing. The fairing is this honeycomb structure that protects the satellite from the initial, during the initial phases of the launch, to protect it from the heat in the atmosphere.
And here we can see
the final mating of the two sides of the fairing, so along the long edge where they bolt together, and this part has to come away flawlessly when we reach the right moment. Then we put on the stickers, and the team sign it and wish the spacecraft goodbye and wish it well on its flight. And here you see that it's already been wrapped in its thermal blankets, so this protects it from the temperatures and keeps everything in a stable thermal environment during the part of the ascent.
Philippe, the next phase then is to roll it out to the pad.
Yes, indeed, and this is what we see here. Those are pictures that were taken 6 days ago, and the overall, what we call the composite, that is the Breeze upper stage with satellite under its fairing layer, are being slowly moved from the preparation area to the tower, where it's then been mated, and this is what we will see, to the first and the second stage, which, as we said, was the original ballistic part. And here what we see on screen is the composite being slowly and very carefully being hosted and then will be mated on top of the rest of the launcher.
Looks like it's been raining there. It was raining when...
Probably even snowing.
Maybe snowing.
It's still... winter is not over there. And what we see now is that the tower and the gantry is being closed for final mating and preparation.
So we are 2 minutes and 30 seconds to launch. Rokot on the pad in Plesetsk in northern Russia. We have various events that we need to look out for. Nick, there is a 14-second sort of, not a wait, isn't there, before liftoff. Can you talk us through what happens between 0 and 14 seconds?
Yep, at what we call end of gyro setting, which is the 0 count, the systems are switched to the internal systems. So at this point, it's basically all systems go, and the systems are initialized, and then at 11 seconds, you get the 4 engines of the first stage igniting, and then the liftoff happens roughly 2.5 seconds later. So that all adds up to about 14 seconds.
Teams concentrating hard at this point now before launch. You can see there on the pad the lightning towers, and here the teams in the mission control center. As we get closer now to the 1 minute mark for the launch of the Sentinel 3B satellite, which will join its twin, Sentinel 3A, in space. Teams have done this many times before. Coming up now to 1 minute to launch. We are going to go silent, switch off our microphones, and watch the launch. We are off. Rocket is hauling itself against the gravity of our planet. The first stage is pushing us away from Earth. We need a lot of firepower to do that. Nick, what's our trajectory?
So at the moment we're heading north-northwest, so we're heading up over the Arctic Ocean, and we're heading in this trajectory because we want a polar orbit when we finally separate, so that Sentinel-3 will be roughly 98 degrees in inclination, which is the angle from the equator to the orbit.
Philippe, what's happening to your satellite right now?
Well, it's starting its journey. I can tell you it's always a little bit of an emotional moment. I think that launching a satellite in orbit is similar to launching a ship at sea. You know, you have worked for it, you've waited for this moment, and here it comes. Very beautiful pictures that we've been able to witness, I have to say, with a clear sky and voila. We also get, I think that everybody's been able to see the strength that there is in this launcher. Our satellite, once it's in orbit, is in a very smooth environment for what concerns at least the mechanical environment, because it's just floating in the air once up there. But now, for this launcher, you can see with this big boost and all the vibration that goes to it, it's a very bumpy ride, really.
It is in the first phase of the flight, isn't it? But right now we have separation of the first stage. We're now burning the second stage, Nick.
Yep, this burns for about 3 minutes and it takes us right over the North Pole, and at the moment we need to accelerate. So we've gained a little bit of altitude, but we need to go fast enough so that when we stop burning we can actually stay in orbit.
And if you look at the front of the launch vehicle, you can see here what we call the fairing. Nick was referring to that earlier. It's the pointy section of the launcher. We don't need it anymore because we are now in space. We've gone through the dense part of the atmosphere and we can jettison that. Philippe, we can see your satellite now for the first time.
Yes, well, those are simulated pictures, yes, but indeed this is what we can imagine, which is that the spacecraft that the teams have seen for the last time when the fairing was closed around it is now really starting its journey in space, because it's really up there and in the forefront of as a spearhead of the breeze launcher.
So we've gone above what's often known as the Kármán line, which is effectively the border with space. It's about 100 kilometers above sea level, 62 miles. What does that actually mean, Nick?
So at this point, the air is so thin that the force required to fly in an aeronautical regime, so like an aeroplane does, is more than actually a rocket needs to fly in an astronautics domain. So this is really the rocket science that needs to keep us there, and it's the boundary between aeronautic ending and astronautic beginning.
And it was identified by a Hungarian-American aerospace engineer called Theodor von Kármán, and he was born in 1881. So we're burning the second stage, getting closer now to the next phase, which will be the second stage shutdown. These images that we're looking at, these are computer-generated images, which are a simulation of what's been planned for the flight. The experts put a lot of information into the computer to generate them.
Dynamics of the loop.
And the second stage shutdown is coming up.
The liftoff time was 175751.
And this is the scheduled moment now for the upper stage to switch off and switch on of the breeze upper stage. So we've lost the second stage, we've switched on the breeze upper stage, we're starting the next part of the journey. Breeze is taking the wheel, Philippe. It's going to take, about another hour and 15 minutes from now. What's Breeze's job?
Well,
Dynamics of the loop.
the Breeze has the important task to bring our satellite exactly on the precise orbit where it should be. In our case tonight, we want to be at the same altitude than Sentinel 3A, just a little bit above for the commissioning phase, 10 kilometers above actually. So the satellite has its own engine and can change its orbit, but this costs fuel, and so it's very important that we have a precise orbit right from the beginning, and that's where it's critical to have a performant and let's say on target third stage like Breeze will very likely do tonight.
It's a little bit like a sophisticated taxi driver. It takes its passengers where they need to go. Nick, it's a fascinating piece of kit, isn't it? Because it's effectively a spacecraft in its own right.
Absolutely, yes. It has to be very autonomous, so it has to really think for itself and be able to decide when to do exactly what it has to do. It has its own onboard computer with guidance, navigation, control. It has its own tracking and telemetry system, so it can talk to the ground and tell the Russian experts what it's doing and when it's doing it. It actually has the capability to restart its engine multiple times and perform different maneuvers, so that it can take its passengers to different orbits, or even multiple satellites to different orbits. So it offers tremendous flexibility, but as you say, it has to be very clever, and it's a spacecraft in its own right.
The Sentinel-3 satellites are a key component in the Sentinel constellation, which of course as a whole provides vital services to the Copernicus program. We're going to take a look now at the kind of services that the Sentinels provide.
With more than half its satellites now launched, the Sentinel constellation is providing a wealth of data on land use, the marine environment, the atmosphere, security, emergencies and climate change. By combining Sentinel satellite data with Earth observations, scientists can develop a clear understanding of many of the vital issues affecting our planet. Sentinel-3, for example, sends back data every day to help scientific projects around the world studying the oceans and the marine environment. Many of these projects, such as EuroHab, which investigates harmful algal blooms, or HABs, can only go out to sea at certain intervals. In EuroHab's case, once every 2 weeks. Sentinel-3 captures a broad view of the production of phytoplankton. The scientists of EuroHab can then take further measurements to break down which species the satellite observed and, crucially, which are toxic. At Plymouth Marine Laboratory, an ingenious device called a smart fin is attached to a surfboard to measure the temperature of coastal water, and the motion of water is measured using a smartphone. Back in the lab, these measurements verify and sharpen an interpretation of the data provided by the instruments on board Sentinel-3.
The temperature of the ocean is a fundamental component of the environment. It controls the physical environment through changes in density together with salinity, which impacts coastal currents. It also controls the biological environment, so the growth and reproduction rates of pretty much all marine organisms are temperature dependent.
While a scientific study can only examine a small part of the ocean, satellites can cover the entire planet. By combining Sentinel-3's data with measurements taken at sea, patterns are detected and applications are tested. At Plymouth Marine Laboratory, scientists are also checking in situ data to determine whether plastic and rubbish accumulation in the ocean can be detected from space.
We are going to do a horizon scanning exercise with all the technologies that are available from Earth observation, and we are considering mainly, because that's our expertise, optical methods, but then we're also considering other remote sensing methods like SAR, and as well indirect approaches.
The Sentinel constellation of satellites is at the heart of Europe's far-reaching Copernicus program, providing real-time information 24 hours a day, 365 days a year on the health of our planet.
Philippe, this is really important stuff, isn't it? These services are hugely important, particularly as the world becomes more and more conscious of the need for sustainability.
Yes, and I think that as we've seen in the movie, it's about satellite, but also we shall not forget the importance of all the data that have been gathered directly on Earth, the so-called in situ data. Also, what we found with Copernicus is that the data is important, of course, but it's mostly what you do with it which is critical. And that's the reason why the Copernicus program is about satellite, but it has also an in situ component, and then it has a service component. And it's really the three together that are delivering, let's say, the overall value of the program. And let's not forget that whilst there are institutional services that have been put in place by the Commission, there is also many commercial companies that are now establishing themselves and that are providing added value services, services that you can buy. So Copernicus is not only better about environment, but it's also really a commercial and economic affair.
In a couple of minutes' time, the Breeze upper stage will be scheduled to switch its engine back on again for the first of two ballistic phases. Nick, what does ballistic mean? We do hear the word quite frequently, but what does it actually mean, and why do we need two burns for this particular mission?
So a ballistic phase is when there's no additional energy added to the system. So it's like a bullet. When you fire a bullet, it's left to its own devices. You give it an initial kick, but then the rest of the travel is in a ballistic phase. So the reason that we have this ballistic phase is that to do a two-burn maneuver is the most efficient way of making a circular orbit. If you want to, when you start with an elliptical orbit. An elliptical orbit is like an egg shape. The most efficient way to make the whole orbit round is to fire at the furthest point, or the apogee. But you have to wait until you reach that time. So during this phase, there's no additional energy required, so you're in a cruise phase.
And I think I'm right in saying that it's Kepler who identified the elliptical orbit, the motion of the planets?
That's right. Kepler identified the three main orbits from which you can determine the motion of the planets around the Sun, and basically any satellite around a planet.
That's quite amazing, really. It was back in 1571 that he was born. He was a mathematician and an astronomer. Apparently, though, I was reading on Wikipedia that he had smallpox as a child, which left him with crippled hands and very poor eyesight. And apparently, he is known as the founder of modern optics and discovered eyeglasses. Or helped, or was one of the important people in discovering eyeglasses, so we have him to thank for our glasses. So the Breeze upper stage getting ready to switch its engine on. The scheduled time in about 20 seconds. Switch its engine off, I meant to say, of course. Getting close now to the end of this burn. There we have the scheduled moment now for Breeze to switch its engine off. So we are now in the ballistic phase. We are cruising without the engine, which we will do for about an hour, and before it switches the engine back on again. We are now going to go over to Plesetsk and talk to Bruno Beretti, who is the Sentinel-3 project manager. He's in charge of Sentinel-3, and also to Patricia Lopez, who is the Sentinel-3B launch campaign manager. She's been leading the teams throughout the campaign. Bruno, let's start with you. I can see Guido there in the background as well. Hi, guys. Bruno, you've been very involved in getting us to the launch today. Now that we've lifted off, what's going through your mind after all that hard work?
Well, at this point I have to say that I had not much time yet to think about the hard work done before. We're still in a kind of the middle of a climax, which is lasting quite long, 1.5 hours, because the liftoff is just begin. But we have been witnessing so far a number of critical movements, and so far everything is nominal. But we are still waiting for the final injection maneuver that will happen only in 1 hour and some minutes from now. And we are not able to witness this. We will only be waiting when our colleague in ESA will confirm to us the arrival of a signal and the fact that the satellite is healthy and talking to us. And only at that moment, I believe that we will probably realize that we achieve the objective to put also the second satellite in orbit and to complete our constellation to get an operational mission.
And Bruno, just briefly, people often talk about the Sentinel-3s as the workhorses of the Sentinel fleet. Why is that?
Well, Sentinel-3 is a bit different from the other Sentinel which has been flying so far or we are under development. Sentinel-3 is a multi-instrument and multi-mission satellite, cover both optical and microwave mission, and has an important objective to provide global coverage of the whole Earth's surface, land and ocean, into a very short time. In fact, with Sentinel-3, with both Sentinel-3 satellites flying, we will be able to give an optical coverage of the overall Earth in 1 day, which is something never achieved before. Just to understand, the predecessor of Sentinel-3 were doing this in 1 week or 10 days.
So that's
and this is allows Sentinel-3 to provide a basis for all the other missions of Copernicus.
So a very important mission. Patricia, you are the launch campaign manager, I think I'm right in saying, for Sentinel 3B. So you've been leading the teams throughout the campaign. What were the highlights for the team during the campaign to prepare the satellite?
I think every day has been very important for everybody here. There was a very good team spirit from day one until the very end. I think if I would have to pick a moment, would be the moment of encapsulation and the moment when we signed the fairing. At that moment we knew that despite the delays we had accumulated in the beginning, we managed to catch up, to go through all the critical activities for the satellite. We knew the satellite was fine. We performed the fueling, we performed the mating with the launcher. So all the critical steps were behind, and we could make it back to the nominal schedule. And at that moment we had the opportunity to sign the fairing with all the names of the people who contributed. It was our way to give the people who were not with us at that moment something back to them.
Well, thank you very much indeed to all of you, and our best wishes now as we go through the ballistic phase, and to all the teams in Plesetsk. We are going to take a break from our program now, and we will be coming back to you in just under an hour at 21:05 local time here in Darmstadt. That's, I believe, 20:05 GMT. We'll see you then. Are you That was 1 hour and 8 minutes ago. We are 1 hour and 8 minutes into the flight of Sentinel 3B. It's a European Earth observation satellite, which is going to help us better understand our planet. It lifted off from the pad at the Russian cosmodrome in Plesetsk on board a rocket launcher, and we've been coasting without the engine ever since for the last 54 minutes or so. We're coming to you live from the European Space Operations Centre in Darmstadt in Germany. And as I mentioned earlier, ESA is doing a live event at the Berlin Air Show for the launch, and best wishes to everybody there. Earlier, we caught up with the Director of Earth Observation Programs, Josef Aschbacher, and here's his overview of the mission.
With the launch of Sentinel 3B, Europe is putting together a fully operational system based on the first batch of Sentinels in orbit right now. With Sentinel 3B, we will have 7 Sentinels in orbit, 2 each of Sentinel 1, of Sentinel 2, Sentinel 3, plus Sentinel 5B. And these satellites are measuring a variety of parameters and providing a variety of information for many people. For example, for farmers, to estimate the amount of crops which is being produced and monitor the state of the agricultural fields. Doctors to see what is the air pollution in a certain area and whether the city where people live in is particularly endangered. Civil protection agents to better respond in case of crisis and disasters like flooding, earthquakes. For ship captains to better navigate their ships and make sure that they are not hitting an iceberg. But also politicians need to know, and they get better information about food security in Africa and to realize what needs to be done to really contain a global crisis which might develop. So these Sentinels really provide fantastic information to a number of people and really are of great economic and societal value for Europe. External studies have estimated that €1 invested in Copernicus brings back about €10 to the economy if all the data are used in a free and open way. And this is one of the success criteria of Copernicus, that these data are for free available for everyone globally. And it's a very good example how Europe works together successfully. The European Union and the European Commission providing leadership and political guidance and co-funding of the system. The European Space Agency being in charge of implementing, developing and operating the space component. EUMETSAT also operating parts of the space component, some of the Sentinels, but also, of course, the member states of ESA and the European Union and industry who is building the space infrastructure. But also user organizations like the European Environment Agency, Frontex, the European Centre for Medium Range Weather Forecast, the Satellite Center in Torrejon. They are all using this data in a routine way for their daily purposes. In short, it's a good example how Europe works at its best.
Josef Aschbacher. I'm Katie Haswell, and I'm with Philippe Goudy, the head of Earth Observation Projects at ESA, and Nick Mardle, who's the head of the Earth Explorer Management Office. And we'll be taking you through the rest of the program. Nick, what's been happening in the launch so far?
So, as you mentioned earlier, we launched an hour and 12 minutes ago, and the initial part of the flight was to burn the first and second stage to perform the main propulsive part of the launch, and then the Breeze KM, or the third stage, the upper stage, took over and fired for roughly 500 seconds to achieve an orbital velocity so that it could stay in orbit, but it's a relatively highly elliptical orbit, so it's very egg-shaped. And then the Breeze shut down, and we started the cruise phase, which is where we are at the moment.
And Breeze will be getting ready to switch its engine back on in a few minutes' time for the second burn. Philippe, while we're waiting for that, let's talk about our satellites. Why are these Sentinel-3 satellites important?
Well, first of all, I think that all sentinels are important because all of the sentinel are bringing their set of data, and it's really putting together those various information that is helping our understanding of the Earth's environment. Now, amongst its variety of mission, one can say that Sentinel-3 is probably mostly focused on ocean, and it has an instrument for ocean temperature, for what we call ocean topography, which is the height and the low of the surface of the ocean, but also what we call ocean color, which is a measure of algae and all the biologies that take place inside the ocean. And we know that more and more oceans are crucial for our environment. Many people live close to the coast. The oceans are also driving the overall climate, or are part of the overall climate loop. And this is really what makes altogether Sentinel-3 very important.
And as we mentioned earlier, the Sentinels come in twos, and Sentinel-3A, the twin of Sentinel-3B, launched 2 years ago in 2016. What is Sentinel-3B going to add to it?
Well, basically all the Sentinel series were designed to work in tandem, and so this is the second half of the tandem. And what it will bring, what Sentinel-3B will bring, is actually more data. And this is with Sentinel-3 and 3B that we'll be able to monitor some of the instruments, the whole Earth in one day, which was never really done with that accuracy before.
Coming closer now to the switch on of the Breeze upper stage engine. That's scheduled in a few seconds' time. You can see there the CGI images of what we're looking at. That's the Breeze upper stage. They're scheduled to switch its engine on. You can see it there, and the satellite attached to it. So we're really entering the next phase now. Nick, why has Breeze switched its engine on again?
So now after the cruise phase, we've reached the highest point of the orbit, but it's no good where it is at the moment. So what we need to do is circularize the orbit so that it's in the same altitude for the whole time that it's flying around the Earth. And it's most efficiently done when we're at the highest point, and that's where we've just arrived at the moment. So the Breeze will burn for 32 seconds roughly, and then it'll switch down, and then we'll be in a circular orbit.
Sentinel-3B was built by Thales Alenia Space. They're experts at building Earth observation satellites. And ESA's remit was to equip the two Sentinel-3 satellites with 4 different types of instruments. And this is sophisticated technology. We're going to take a closer look now at the instrumentation on Sentinel-3B.
The Sentinel-3 satellites carry a suite of optical and microwave instruments working in synergy. Sea, land and surface temperature radiometer measures global sea and land surface temperatures across a wide area, with an accuracy of better than 0.3 degrees Celsius. The Ocean and Land Colour Instrument measures 21 distinct spectral bands. It monitors a large area as it passes overhead. The synthetic aperture radar altimeter provides total coverage of the Earth's surfaces. Along with the other instruments in the topography payload, the microwave radiometer and precise orbit determination, it accurately measures land and sea height.
Philippe, this is cutting-edge technology, isn't it?
Yes, really, all this suite of instruments are really indeed state-of-the-art, I would say. And one has to realize what it takes. We were mentioning in the movie the temperature measuring instrument. I want to stress out, looking from 800 kilometers, you're monitoring the sea temperature with an accuracy better than 0.3 degrees. Anyone who has been putting 2 thermometers in our room and finding that the measurements don't really coincide can see what it takes to really bring such accuracy from above. Similarly, the radar altimeter, where from 800 kilometers will measure the sea height to precision that in the order of 1 centimeter. And again, one can think about how much care you need to put into building and also calibrating and making sure that those instruments remain stable over time.
We're getting close now to the scheduled separation. We're about less than a minute away. Nick, we're going through a set of orientation maneuvers up here, aren't we? The upper stage is, well, we can't really see it twisting and turning too much, but it is actually doing that.
Yes, that's right. The final activities that the rocket and the breeze and the satellite go through is a rotation maneuver, so that effectively it's flying backwards, and at that point you get the separation, so the two will start to drift apart, and then the breeze is in the right orientation to do a deorbit maneuver, so that it can then do the deorbit to move away from the operational orbit of Sentinel-3, so it doesn't cross again, but then later so that it can deorbit correctly and land safely in the sea.
Sometimes people refer to the separation maneuvers as the space ballet. And we're getting closer now to the scheduled separation time, which of course we can't actually confirm at this moment, can we, Nick, because of the telemetry?
That's right. Although the spacecraft and the breeze are separating, we can't see that because our space stations, our ground stations, don't actually have line of sight. It's as if the spacecraft is below the horizon for our ground stations. So until it comes above the horizon, we can't be sure what the situation is.
So what's happening now?
So now the teams are waiting. The ground station is ready. The antenna is pointed at the horizon, waiting for the moment that the signal comes in, and then we'll know that the spacecraft is arrived at the right point at the right time, and from there we can work out what the situation is with the satellite, if it's doing what it should do, or there's something that we have to intervene with.
Just remind everybody, Philippe, what we're looking at, the breeze upper stage with the satellite attached.
Indeed, and we shall have, let's say, the animation showing the separation for the spacecraft, which is really the time when it starts flying on its own, and it starts its own life, because this is time where it will initiate its own automatic sequence in itself. And so it's really the crucial moment that the confirmation of which we will be waiting as soon as it gets over the horizon over the Copernicus station.
Now, while we're waiting for that confirmation, we've been seeing the teams in the mission control room, but that's the tip of the iceberg. There are lots of teams working on the Sentinel project. Another one of them is the project support team. And I did get a chance to talk to them earlier.
This is the project support team. So ESOC is controlling the immediate operations of the satellite, but of course many analyses have to be done in the background and checks have to be performed. So this team is composed of the team of the European Space Agency, ESA, and our industrial prime contractor, Thales Alenia Space from Cannes. And of course there are many people also in the background supporting if there would be questions and problems to be solved. So you can see here, for example, all the disciplines are located, and the most critical ones is the electrical power. It's like any electrical machinery needs power. So this is the most critical. We have to bring the satellite into a situation where the solar array is deployed and is collecting power to charge the battery. And this is done here. And then, of course, the AOCS is a very important function, which is also represented here. thermal control, not to forget, let me say, like any, let me say, machinery, it is cold, it can be cold and it needs to be warmed up, or it is warmed and it needs to be cooled down. So all these analyses and checks are done, background checks are done in the support room. We work since 2007 from the design of the spacecraft on this let me say, for this important event. Okay, this is the second time, and we are very, let me say, enthusiastic to bring it in orbit, like for the S3A.
So it's all about teamwork, and also teamwork between ESA and EUMETSAT, because the European Space Agency operates the Sentinel satellites in conjunction with the European Organization for the Exploitation of Meteorological Satellites. EUMETSAT helps to exploit the information that the satellites collect, and it is vital for helping to understand climate change and for weather forecasting.
So, Chris. In EUMETSAT's dedicated Copernicus control room at its headquarters in Darmstadt, engineers work 24/7, commanding and monitoring the Sentinel 3A satellite. Now they're getting ready for Sentinel 3B, and twice as much data.
In the first 6 months of operations, we put in the same amount of data into our archive as in all the previous programs through all their lifetime. Everything's bigger, better, faster. The amount of data, the accuracy of the data gives us more chance to actually identify parameters more accurately, which of course leads to improved climate management, improved weather forecasting, because we have more accurate data.
After the initial commissioning phase, the twin Sentinel-3 satellites will fly in series around the Earth, approximately 40 minutes apart, enabling them to cover the entire planet in 2 to 3 days. The Copernicus team here processes and analyses ocean data collected by Sentinel-3's suite of instruments and turns it into useful scientific products.
Sentinel-3 is a mission that's primarily focusing on monitoring the ocean's different parameters, for example, sea surface temperature, sea surface height, wave height, and also sediments and ocean colour parameters, where you have things like plankton or sand, transported by the ocean.
Changes in global ocean temperatures, visualised here with 2016 data, can have long-term implications for future climate. But near real-time data from Sentinel-3 is also fed into shorter-term weather forecasts.
The temperatures of the ocean is what provides the energy to drive the weather system. So if you've got areas of warm in the ocean, this can provide enough energy, for example, to feed a hurricane. So it is the energy store of the Earth.
Over more than 30 years and with multiple missions, EUMETSAT has transformed weather and climate forecasting in Europe. Sentinel-3B will double the capability of this programme of ocean monitoring satellites, improving global predictions for the state of the seas, future climate and weather forecasts.
We're going to go back now to the mission control room here at the European Space Operations Centre and speak with Rolf Densing, who's the Director of Operations, and Paolo Ferri, who's the Head of Mission Operations Department. Gentlemen, thank you very much indeed for coming to chat with us. Rolf, let's start with you. How important are missions like this for ESOC?
Well, let's consider that European taxpayers have invested a lot of money over the last 50 years to build up this unique world-class operations center. And so it's good news that they now operate this institutional mission out of the European institutional control centers. So I must say it has been exciting, it has been fun, it's good for our people. It's a very interesting mission. So we like challenges, we like to fly satellites, we like the excitement of launch and early operation phases. And this is the excitement that we are feeling here today.
And what are you most proud of, Rolf, over these last 4 years? I guess it's the teamwork and the teams you've been, who've helped to bring us to this.
Well, so far, most importantly, everything has gone flawless. So we have managed to bring all of these satellites in a really operational state. Everything went as it should be, despite of challenges we had in a very early launch of the Sentinel series. We had a collision avoidance during a collision warning during a launch phase, and I cannot think of any other place in Europe that would have mastered it the way our colleagues did it over here in ESOC, and this was before my time, so I cannot personally take credit for that.
Thank you very much indeed, Rolf. Paolo, over to you. You've launched 7 Sentinels in 4 years. What have you learned during that time?
A great deal. The team, of course, has done these operations many times. The satellites are different from each other, okay. The Sentinel 3B is identical to 3A, but they are a series, and we reduced dramatically the effort required for training, for example, because in the beginning everything was new. In the end, we had a lot of things that our team had learned. The systems that were developed are very common across the satellites, and basically for every mission they get a little bit better. So there was a huge learning process.
And it's been a really fast turnaround between missions, hasn't it? Which I guess is hard work, but also a great opportunity for the teams.
Yes, absolutely. You see people very rapidly growing from one position to the next. It's extremely efficient to give career opportunities within such a integrated team. So people that maybe are playing a certain role in the beginning of the 4 years, they grow, and in the next launches they play a higher level role. We have the opportunity also to train and prepare also young engineers and young colleagues. So it's been really an incredible opportunity for the team.
Well, best wishes to all of you now as we get closer to the acquisition of Signal. And thank you very much indeed, gentlemen. Nick, what's happening right now? What are we waiting for?
So we're waiting for 2 things. The first is that the spacecraft fly over the Russian monitoring ground systems, so that then they can have confirmation of the rocket part of it. But then we're also waiting for Sentinel-3 to arrive at Kiruna. Now, Kiruna is our first ground station, and from there we'll see that all of the initial activities have happened correctly after the separation. So all of the autonomous onboard commanding has been performed, and that the transmitter has switched on, and the attitude control systems are starting to work properly, and hopefully we'll even start to see the deployment of the solar array. So we're all waiting for this. This should all have been happening whilst we're waiting after the separation, and we're just now waiting for the spacecraft to reach a point where the ground station at Kiruna can see it, and then we'll know for sure that we have a mission.
And what happens next, Philippe?
Well, when we have a mission, then there will be a so-called early operation phase, the LEOP phase, where we will stabilize the spacecraft, make sure, turn it on gradually, and make sure that everything works well on the platform part of it. Then a little bit later on, beginning of May, we will, in a staggered fashion, turn on each of the instrument, finishing by SLSTR, which has to be cooled down first. And then each of those instruments will undergo a series of tests and will be compared with their predecessor, with ground measurements, to really do what we call calibration and make sure that what they measure correspond to the actual physical parameter. And this will take about 5 months or so. But we are, of course, this is all pending the successful separation that we're all waiting for its confirmation, I would say, any time now. And we shall be whether the signal is appearing on the Kiruna station, as we are now waiting on the screen there.
So we're going to go quiet and wait for that acquisition in a second. But just before we do, can you describe to everybody what they need to look out for on the top right-hand screen? What will they see?
So here they'll see the signal as it's being received at Kiruna. So you should see a big peak in the center of the screen, which means that the right frequency is being received by the antenna, and once we have that, then we can know that we've got the transmitter on.
So we'll sit back now, turn our mics off, and wait for the peak.
Так, Москва, что у нас? Москва. Что у нас? Так, Москва.
We have signal acquisition. Very good.
Алло, Москва. Алло, Москва. Ответь. Алло, Москва.
Some audio the loop.
Yes, with this I was about to call you. So from first TM check, I can see that the spacecraft mode is in it. IOCS is in rate dumping mode as expected, and separation has been detected, and the solar array wind deployment is currently ongoing.
Okay, thank you, Sam.
Okay, we can announce that we have the spacecraft, and was exactly at the time in Kiruna. The sequence of dumping is ongoing. Spacecraft, of course, is separated. The solar array deployment sequence started, and if we are lucky enough, we can see array fully deployed before the end of this pass.
So, Pier Paolo Emanuele there telling us that we
Just they said solar array fully deployed.
Giving us information there which is very positive. Quick comments from you too, Nick.
So the fact that we've deployed the solar array means that the spacecraft is power safe, and so we can take our time to perform the next operations in peace and calm.
And our best wishes to the teams in the MCR building for the next phase of their operations. Philippe.
Yeah, it's really thrilling. We have a mission, and I think we can really congratulate and thank all of those who have participated, who have contributed and lead us to this really flawless launch. I think of all the people in industry, in Thales, but also in the consortium. All the people in ESA, in ESTEC, in ESOC here, but also all the people that have been supporting the European Commission, of course, and all member states.
Well, thank you very much indeed, both to you, Nick Mardle, and you, Philippe Goody, for joining me here in the commentary box. We are going to close our program down now and say goodbye.
Goodbye.
And we will leave you with Paolo Ferri.
Deployment sequence is started.
Yes, Kathy, thank you. Well, as you see, everybody is very happy here, but they are super busy. They are verifying the status of the spacecraft. It's nice to see just on the screen this signal. It arrived perfectly on time. Now, what happens now? The team has to work the whole night to stabilize the spacecraft, confirm that the array is deployed, confirm that all the systems are working, and gradually bring it up to a status that then will bring it to the initial phase of the mission. One important thing over this night will be the activation of the Star Tracker. Star Tracker is a little telescope on board that we use to control the attitude of the satellite. Next coming days, still very busy team, but we hope, if everything goes well, and the good start, of course, is a very good sign. We hope that by Friday night, later Saturday morning, this critical phase will be over. We can hand over to the next phase, which, as already was said, will be very long. Again, the excitement, we cannot enjoy the excitement at the moment because we have 20 minutes in front of us of intense communication with the spacecraft before it goes below the horizon of the Alaska station. Then we will pick it up again in in the Antarctica over Troll, and then back. So this will repeat itself every hour and a half for the next few days. Yes, this is the activities of the coming days. This has been a very exciting day for everybody, and what is left to me is to wish from ESOC Mission Control to all people on Earth a pleasant evening.
Señorita della Notte, well done.
Thank you.